Hi, I thought I'd help you a little bit with some of your homework in section 2.5. This entire section focuses primarily on a very special limit, namely the limit as u goes to 0 of sine u over u equals 1. I've graphed over here on the side the function sine u over u. So this is y equals sine of u divided by u. This function is not defined at u equals 0, and you notice I have a little hole here, but we can see that if we approach 0 from either the left or the right, this graph heads up here towards the value where this hole is located, and that value is 1. So the limit as u goes to 0 of sine u over u is 1, and this is a limit that we're going to use quite a bit in looking in the exercises in this section. So let me flip forward to some of the exercises you've been asked to do. You slide on down here, get past 2.4. The first one you've got on 2.5 is listed right here. And with this particular limit, you're asked to determine what happens with an expression when x goes to 0. In this case, the expression is sine of 3x divided by x. So this is almost sine of u over u. For this to be sine of u over u, the u has to be 3x. I don't have 3x in the denominator. It is not of the form sine of u over u. I can place that in the denominator by putting a 3 there and then compensating by putting a 3 on the outside. And if I do that, then the expression that I have here, this portion of this expression, is of the form sine of u over u. Of course, now we have to ask an important question. In this expression, sine u over u, where u is being played by 3x, is u going to 0? Well, notice that x is going to 0. If x is going to 0, then certainly 3 times x is going to 0. So it is the case that I'm looking at sine u over u with u going to 0. So this quantity right here, the sine u over u portion of this, is going to head to 1 as u goes to 0, right? U in this case being 3x. And u is going to 0 because x is going to 0. So this portion right here is going to 1. I've got 3 times something that's headed towards 1. So I'll get 3 times 1, which is 3. And that's your answer for this first problem. Let's take a look at some more problems. Let me skip over here to the second page of problems you've got. Right now we've got problem 3 in section 2.5. Let me look on my sheet and I'll write that problem in here. Problem 3 in section 2.5 is a limit as x goes to 0 of 3x divided by the sine of 5x. So I want to make note of some things. First of all, we've got this special limit. This special limit is limit as u goes to 0 of sine u over u, and it's equal to 1. I mentioned we'd use that quite a bit in this section. Well, if sine u over u goes to 1 when u goes to 0, then it's certainly the case that if I look at the reciprocal of that quantity, namely u over sine u, that u over sine u will also go to 1 when u goes to 0. This quantity is exactly the one that we're going to be looking at in this particular problem. Let's go back up here now and look at our expression. I've got a limit as x goes to 0 of 3x over sine of 5x. This would be u over sine of u if I had a 5x here instead of a 3x. What I'm going to do is I'm going to get a 5x there just by doing a little bit of algebraic manipulation. So limit as x goes to 0, pull the 3 out front. Now I'd like to have a 5 up in the numerator to multiply by my x. So I'll put one there, but I'm going to have to compensate, and the way I'll compensate for that is by multiplying by a 1/5. And so now this quantity right here is of the form u over sine of u, and since x is going to 0, this term 5x, which I'm calling u, is going to 0. U over sine of u with u going to 0. So this quantity is going to go to 1. So my entire limit will head towards 3 times 1 times 1/5. And 3 times 1 times 1/5 is 3/5. Let's take a look at another problem. The next one we have here is problem number 5 in section 2.5. Problem number 5 in section 2.5 is a limit as x goes to 0 of sine 4x divided by sine of 2x. There's actually a couple different ways you can work this problem. Let me first show you how to work this problem by using the special limit that we have in this section. So to do that, I'm going to break this expression, sine 4x over sine 2x, up into two pieces. So first let me rewrite it in this form. Sine of 4x over 1 times 1 over sine of 2x. So now if I want to make this look like sine of u over u, well, I'll need a 4x in the denominator. Well, I can't put a 4x in the denominator unless I compensate by putting a 4x in the numerator. So I'm going to do that right now. Let me remove these. I'm going to put a 4x down here. I've got to get a 4x in the numerator, but I'm thinking ahead. And I'm thinking, well, I've got a sine u here. I'd like to have u here. I'll need an x up here. So when I put my 4x in the numerator, I'll put a 4 here, and I'll put an x here. So now taking a look at this, I've got this first expression, which is sine u over u. Sine of u over u, with u playing the role of 4x. Since x is going to 0, the 4x is also going to 0, so I get sine of u over u with u going to 0. This part's going to go to 1. I still have to handle this piece. In this particular piece, I've got sine of u in the denominator, but I don't have u in the numerator. To get u in the numerator, I need a 2. I can put that there if I compensate by multiplying by a 1/2. If I do that, I then have u over sine of u with u going to 0, and as a result, this quantity here is also going to tend towards 1 when x goes to 0. So all told now, when I take my limit, I'll get 4 times 1 times 1 times 1/2, which is 2. Now I commented at the beginning that we could do this another way, right? So let me show you that very quickly. One other way that I could do this is by using a trigonometric identity. Sine of 4x. Well, let's see. 4x is 2 times 2x. So the identity that I'm going to use here is that sine of 2 times theta is 2 times sine theta times cosine theta. Right here I've got sine of 4x. That's 2 times 2x. So I'm thinking of the 2x as being my theta, and as a result I can rewrite the numerator by using this identity that I just wrote down above, and I'll get 2 times sine of theta, which is 2x, times cosine of theta, which is 2x, all divided by, well, in the denominator I've still got sine of 2x. I can then come in here and cancel the sine 2x's off. I'm left with 2 times cosine of 2x, and cosine's a very nice function. I can just evaluate it, put the x equals 0 in. 2 times 0 is 0. Cosine of 0 is 1. 1 times 2 is 2. So regardless of what route you take here, you're going to get a value of 2. Let's take a look at problem 7 in section 2.5.